May 14, 1966. Somewhere over North Vietnam, an F-105 Thunder Chief pulled off target trailing black smoke from its left wing route. The pilot, his name doesn't appear in the declassified strike report, nursed the aircraft southeast toward the Tonkin Gulf while his flight lead called in the hit assessment. According to the after-action summary filed that evening, the strike package had put 24 750-pound bombs across the target area. Direct observation confirmed at least 6 impacts on or immediately adjacent to the structure. The bridge remained standing. That word, standing, appears over and over in the operational records from Rolling Thunder. Hundreds of sorties across multiple years, and the same flat assessment kept showing up in report after report. Damaged, partially collapsed, repaired, standing. The target was a road and rail bridge in Thanh Hóa Province, about 70 miles south of Hanoi, spanning the Song Ma River. The Vietnamese called it the Ham Rong. American pilots had a different name for it, one that stuck because it captured something the official language couldn't. They called it the Dragon's Jaw. And by 1966, it had already earned a reputation that no other structure in the war could match. The bridge wasn't just a target, it was becoming an obsession, a concrete and steel monument to the limits of American air power at a moment when air power was supposed to have no limits. The first organized strikes against it had gone in more than a year earlier, on April 3, 1965, when the Air Force launched a dedicated mission involving 79 aircraft. That raid cost 2 F-105s. The bridge didn't fall. A second strike followed the very next day. The bridge didn't fall then either. What made the Dragon's Jaw so maddeningly difficult wasn't any single factor. The structure itself was a Soviet-designed, reinforced concrete and steel beam bridge, roughly 540 feet long, sitting on massive concrete abutments sunk deep into the riverbanks. It had been built between 1957 and 1964 with Chinese engineering assistance, and the Vietnamese had over-engineered it deliberately. The abutments alone were enormous. One source describes them as 16 feet in diameter at the base. Conventional bombs, even when they hit, tended to gouge the roadbed or buckle the steel spans without compromising the structural supports that actually held the thing up. Repair crews, working mostly at night, could patch the driving surface in days, sometimes hours. The bridge also sat in a valley ringed by karst limestone hills, which meant the North Vietnamese could pack anti-aircraft positions into elevated terrain on both sides of the approach. By mid-1966, the defenses around Thanh Hóa included 37mm and 57mm guns in overlapping fields of fire, with radar-guided systems arriving later. Flying into that valley was like flying into a funnel lined with guns. If you've got a theory about what finally killed the Dragon's Jaw, drop it in the comments. I want to hear it before we get there. And if this is the kind of history that keeps you watching, hit subscribe and leave a like so the channel keeps digging into stories like this one. The Air Force kept going back. So did the Navy. Between 1965 and the bombing halt in 1968, American aircraft flew hundreds of sorties against this single bridge. The numbers don't quite register until you line them up. 871 sorties is the figure most commonly cited. 11 aircraft lost. The Dragon's Jaw survived all of it. Damaged repeatedly, yes. Knocked temporarily out of service a handful of times, but never destroyed, never dropped into the Song Ma. Every time the bomb damage assessments came back, the conclusion was the same. The bridge was still there. Somewhere in the Pentagon, planners must have started to wonder whether the cost-benefit math made any sense at all. An internal Air Force analysis from the period calculated that the United States had spent roughly $9.4 million in ordnance alone trying to destroy a bridge worth about $200,000 to build. $9.4 million against $200,000. And the bridge was still standing. The problem wasn't courage. American pilots flew into that valley knowing full well what waited for them. The problem was physics. The weapons they carried simply could not do what the mission required. Why did the North Vietnamese build this particular bridge so heavily? The river itself mattered more than any military foresight. The Song Ma is deceptive. For most of its length through Thanh province, it looks manageable. A muddy, slow-moving waterway, maybe 300 feet across during dry season. But the monsoons transform it. Water levels can rise 15 feet in a matter of days, and the current carries debris with enough force to damage anything standing in its path. Soviet engineers advising the project understood this. According to a 1971 Defense Intelligence Agency assessment of the structure, the bridge's design reflected flood loading calculations far beyond what the traffic requirements alone would have demanded. The Soviets weren't building to survive American bombs. They were building to survive the river. The result was a structure that happened to be almost perfectly resistant to the weapons Rolling Thunder pilots carried. Two massive, reinforced concrete piers rose from the riverbed, each sunk into bedrock beneath the silt. The western abutment was anchored directly into the karst limestone of the hillside. A pilot making his bomb run would have felt the valley close around him as he descended. The hills on either side funneling the approach, the river flashing below at maybe 400 knots, the whole airframe shuddering as flak started reaching up. He'd pickle his bombs and pull, the G-forces shoving him down into the ejection seat hard enough to compress his spine, and then he'd be climbing out over the ridge while his wingman called the hits. The hits that didn't matter. A 750-pound general-purpose bomb, the M117, the workhorse of Rolling Thunder, could punch through a few feet of earth or shatter a wooden structure completely. Against 16-foot diameter concrete abutments designed to resist monsoon flooding, it was the wrong tool. Direct hits on the road deck would blast craters in the driving surface, twist the steel I-beams, sometimes even shift a span laterally by several feet. Dramatic-looking damage. But the piers held, and the abutments held, and as long as those held, the bridge could be repaired. The North Vietnamese knew this too. Repair crews staged materials in caves and revetments within a few hundred meters of both ends of the bridge. Replacement steel beams, pre-cut timber, gravel, and sand. A DIA estimate from 1967 noted that repair gangs, numbering up to several hundred workers, could restore basic vehicle traffic across the bridge within 72 hours of a major strike, sometimes faster. One assessment noted a turnaround of under 48 hours. So, the math kept getting worse. American pilots risked their lives to create damage that lasted 2 or 3 days. The bridge absorbed punishment and shed it again. Temporarily disrupted, never structurally compromised. The Air Force tried heavier ordnance. They tried bullpup missiles, which were essentially radio-guided bombs with a small rocket motor. The bullpup carried a 250-pound warhead. Against those abutments, a pilot later described the impact as looking like a mosquito bite. More bravery, more sorties, bigger strike packages. None of it would have changed the outcome. The mission needed a fundamentally different kind of weapon. One that didn't exist yet. April 3rd, 1965. 8:45 a.m. local time. The first dedicated strike package against the Dragon's Jaw was already airborne. 46 F-105s carrying bullpup missiles and 750-pound bombs, supported by 21 F-100 Super Sabres flying flak suppression, plus a dozen other aircraft in various escort and reconnaissance roles. 79 aircraft committed to a single bridge. The mission commander was Lieutenant Colonel Robinson Risner, a Korean War ace with 8 kills who would later spend 7 years as a prisoner of war in Hanoi. Risner led his flight down into the valley that morning, expecting results. The bullpup was supposed to solve the problem. A pilot would fire the missile from several miles out, then guide it to the target using a small joystick in the cockpit while watching a flare on the missile's tail. The problem was fundamental. To guide the weapon, you had to fly straight and level toward the target, toward the guns, for the entire flight time of the missile. No jinking, no evasive maneuvering. A steady hand on the stick while tracers floated up. The bullpup had been designed to kill tanks and bunkers. Its warhead weighed 250 pounds. Against a bridge built to resist a river that could rise 15 feet overnight, 250 pounds was nothing. Risner's pilots put multiple bullpups into the bridge structure that morning. The after-action report noted scorch marks on the concrete. The abutments were untouched. You might think the answer was simply to bring bigger bombs. The Air Force thought so too. The next day, April 4th, they sent 30 F-105s back with heavier general-purpose ordnance. 2 more aircraft went down. The bridge stood. If Washington had paused after those first 2 raids and waited for a precision weapon to mature, even 6 months, even a year, the entire calculus might have shifted. Fewer pilots in prison camps, fewer aircraft at the bottom of the Songma Valley. They didn't pause. Instead, the strikes continued through 1965 and into 66, each one a variation on the same losing formula. Bigger formations, different approach angles, mixed ordnance loads, heavier bombs. The North Vietnamese, meanwhile, kept adding guns. By late 1966, intelligence estimates counted over 300 anti-aircraft positions within range of the bridge. SA-2 surface-to-air missile sites appeared on the surrounding ridgelines. The defenses grew faster than the tactics evolved. Every few weeks, another strike package would thread that valley, and every few weeks, the bridge damage assessment would come back reading the same way. Spans damaged, but abutments intact, bridge still serviceable. The temperature inside an F-105 cockpit on a low-altitude bomb run in Southeast Asia could exceed 130 degrees. Pilots flew into that heat, into those guns, to scratch concrete. 871. That's the official sortie count against the Thanh Hóa Bridge between 1965 and 1968, when President Johnson halted bombing operations north of the 20th parallel. 871 individual combat missions flown against a single structure less than 600 feet long. The losses accumulated in a pattern that reads like erosion. 2 aircraft on the first day, 2 more on the second, then a steady bleed across the months and years that followed. An F-105 here, an F-4 Phantom there, sometimes damaged badly enough to limp home, sometimes not coming home at all. 11 confirmed lost. The actual number of aircraft damaged but recovered is harder to pin down. One Air Force historical study references significant airframe damage on dozens of additional sorties without providing a firm count. The records from this period are uneven. Certain missions generated detailed after-action reports, while others left almost nothing. What the records do show is a campaign that kept doubling down on a losing hand. In June of 1965, the Air Force sent in flights carrying 2,000-pound bombs, nearly triple the weight of the M117s used on the early raids. The heavier ordnance cratered the road deck more impressively. Reconnaissance photos showed twisted steel and gaping holes in the driving surface. The piers didn't move. By August, repair crews had the bridge carrying truck traffic again. In 1966, Navy A-6 intruders from the carriers on Yankee Station joined the effort, bringing their own ordnance and their own approach profiles into that same valley. The Navy lost aircraft too. According to a 7th Fleet summary, carrier-based strikes against the Thanh Hóa Bridge between 65 and 68 resulted in at least 3 aircraft shot down, with additional losses categorized as operational rather than combat-related. The distinction between shot down and operational loss could be thin when an aircraft took flak damage and then crashed on approach to the carrier. A detail that goes nowhere but is worth mentioning. At one point, planners seriously considered using the Carolina Moon mission profile, which involved C-130 Hercules transports dropping mass focus bombs upstream of the bridge at night, letting the river current carry them into the piers. The weapons were essentially floating mines. The first attempt, in May of 1966, failed completely. The C-130 was shot down. All the weapons missed or malfunctioned. The concept was abandoned. By 1967, the bridge had become something more than a military target. It was a symbol on both sides of the war. The North Vietnamese featured it in propaganda, celebrating the bridge's survival as proof that American technology could be resisted. Hanoi radio broadcast reports after each failed strike. The phrase ham rung, dragon's jaw, entered the vocabulary of the war as shorthand for defiance. On the American side, the symbolism cut the other way. Pilots assigned to Thanh Hóa strikes understood they were flying into a problem that bombs alone hadn't solved in 2 years of trying. Morale didn't collapse. These were professional military aviators, and they flew the missions they were given. But the frustration was real. One pilot, quoted in a post-war Air Force oral history, described the Thanh Hóa Bridge briefings as the same slides, the same target photos, the same bomb damage assessment that said we'd have to go back. The same slides, the same photos. The North Vietnamese defense network around the bridge kept maturing. What had started as a handful of 37mm positions in 65 had grown into an integrated air defense system by 67. Radar-directed guns, SA-2 batteries on the surrounding hills, MiGs scrambling from bases further north to intercept inbound strike packages before they even reached the valley. The cost of approaching the bridge went up every single month. American electronic warfare capabilities improved too, but the fundamental equation hadn't changed. You still had to put dumb iron bombs onto a target that dumb iron bombs couldn't kill. November 1st, 1968, Johnson's bombing halt took effect. The Dragon's Jaw got a reprieve that would last more than 3 years. During that pause, the bridge sat in its valley collecting minor rust and minor repairs, still carrying supplies south along Route 1A, still intact. The North Vietnamese used the time to strengthen the defenses even further. Somewhere in the American defense industrial pipeline, though, a weapon was moving from prototype to production. It had been tested in the desert. It worked on a principle so simple that engineers at Texas Instruments had struggled to convince the Pentagon it was worth funding. A bomb that could steer itself, and for the first time, actually hit what it was aimed at. The bridge didn't know it yet. Nobody in Thanh Hóa province did. A small metal canister bolted to the nose of a standard M117 bomb. That was it. The entire revolution in air warfare came down to a seeker head, a set of pop-out canard fins, a computer guidance unit that weighed less than 30 pounds, and nothing else. The Paveway program at Texas Instruments started in 1964, before the first bullpup had even scorched the concrete at Thanh Hóa. Weldon Word, a quiet civilian engineer working out of the company's Dallas facility, had proposed something that sounded almost too crude to work. Take an existing bomb, any dumb bomb already in the inventory, and strap a laser-seeking guidance kit onto it. A designator on the ground or in another aircraft would paint the target with a laser beam. The bomb would follow the reflected energy down. No radio link for the enemy to jam. No joystick requiring the pilot to fly straight into the guns. Release the weapon, turn away, let physics and optics do the rest. The Pentagon was skeptical. According to a 1968 program review, senior Air Force ordnance officials questioned whether a guidance kit costing a few $1,000s could meaningfully improve a weapon that cost a few hundred. The institutional assumption was that accuracy required complexity, and complexity required money. Word's team kept testing anyway, dropping modified bombs on target ranges in the West Texas desert, refining the seeker sensitivity, adjusting the fin geometry so the canards could steer a 2,000-pound bomb through the last several thousand feet of its fall. The test results were difficult to argue with. Unguided bombs dropped from medium altitude in Vietnam had a circular error probable of roughly 460 feet. That meant half the bombs landed within a circle nearly 1,000 feet across. Against a bridge 56 feet wide, you could drop hundreds of weapons and hit the abutments only by luck. The Paveway guidance kit shrank that error to under 20 feet. A single bomb could now be placed precisely on an abutment or a pier, on the exact structural point where 2,000 pounds of high explosive would do catastrophic rather than cosmetic damage. Word's team had the weapon ready for combat evaluation by 1968. Early deployments in the southern portions of North Vietnam and in Laos confirmed what the desert tests had shown. Single bombs were destroying targets that had previously required dozens of sorties. A bridge span in Laos that had survived repeated conventional strikes was dropped by 2 Paveway-equipped F-4 Phantoms on their first pass. The bombing halt kept the Paveway away from the Dragon's Jaw for 3 more years. When the halt lifted in 1972, the weapon and the bridge would finally meet. 12 bombs. One afternoon. The western span of the Thanh Hóa Bridge dropped into the Song Ma River at approximately 1:30 p.m. on May 13, 1972. 14 F-4 Phantoms from the 8th Tactical Fighter Wing, the Wolfpack, based at Ubon Royal Thai Air Force Base, made up the strike element. The mission profile bore almost no resemblance to the raids of 65. No low-altitude runs into the teeth of the guns. No pilots wrestling joysticks while flying level through flak. The Phantoms came in above the effective envelope of most of the light anti-aircraft positions, released their weapons from standoff distance, and turned away. Pave knife targeting pods mounted on designated aircraft painted the bridge abutments with invisible laser energy while the bombs fell. The defense network around the bridge had grown monstrous during the bombing halt. According to 7th Air Force intelligence summaries prepared before the mission, the Thanh Hóa complex now featured an estimated 400 anti-aircraft gun positions, multiple SA-2 batteries, and early warning radar coverage extending well beyond the valley. The North Vietnamese had spent 3.5 years fortifying a position they knew the Americans would revisit. All of that preparation was calibrated against aircraft flying low and slow with dumb ordnance. The PEVWay changed the geometry so completely that the defenses were aimed at a war that no longer existed. The Wolfpack's crews had rehearsed the strike in detail. Flight lead for the first element carried 2,000-pound PEVWay 2s, GBU-10s, in the nomenclature, while other aircraft in the package hauled 3,000-pound M118s fitted with the same guidance kits. The designator aircraft had the hardest job. Those crews had to hold their targeting pods steady on the aim points while the weapons tracked downward, which meant predictable flight paths for 15 to 20 seconds during the terminal phase. The vibration through the airframe at combat speed made precision pod work physically demanding. Backseaters operating the pave knife system had to keep a small crosshair locked on concrete from miles away, while the aircraft bounced through turbulence and their own pilot maneuvered against SAM launches. 12 bombs were guided onto the bridge. The first impacts hit the western abutment and the adjacent pier. 2,000 pounds of tritonal detonating against the exact structural points that 7 years of conventional bombing had failed to crack. The blast effects were not distributed across the road deck or absorbed by replaceable steel spans. The energy went into the concrete and stone that held the bridge up. Reconnaissance photos taken within hours showed the western span collapsed downward into the river. The road deck buckled and sagging at a grotesque angle. The abutment was visibly fractured through its full width. Destroyed western span. One abutment severely damaged, bridge impassable to traffic. That assessment from the initial bomb damage report used language that had never appeared in 7 years of Thanh Hóa strike evaluations. Every previous report had included qualifiers: damaged, serviceable, repairable. This one didn't. The Phantom crews felt the concussions even at altitude. Multiple post-mission debriefs reference the visual impact of the detonations, columns of smoke and debris rising hundreds of feet above the river valley, visible from the egress route as the formation turned south toward Thailand. One backseater described watching the span go down through his targeting pod display and not quite believing the image was real. After years of institutional memory built around this bridge's invulnerability, the sight of it actually falling registered as something close to surreal. The strike package returned to Ubon without losses, 0 aircraft down, 0 battle damage serious enough to affect operations. The most heavily defended bridge target in the history of aerial warfare, and the attacking force came home intact. 79 aircraft and multiple losses on the first day in 65 versus 14 Phantoms and no losses on the last. The numbers speak for themselves. Risner's pilots had as much courage as anyone who flew over that valley. What they lacked was a bomb that could hit a 20-foot aim point instead of scattering across a 460-foot circle. The Dragon's jaw was broken. The North Vietnamese would attempt repairs over the following months, and follow-up strikes with additional paveways would knock the work down again each time. The bridge never fully recovered. October 6, 1972, less than 5 months after the Wolfpack broke the Dragon's jaw, follow-up strikes with paveways dropped the remaining spans into the Songma. The bridge that had absorbed 871 sorties across 7 years was finished in 2 afternoons of precision bombing. The Air Force spent the next decade figuring out what that meant. You might think the lesson was obvious. Smart bombs work. Build more of them. But military institutions don't pivot that cleanly, and the post-Vietnam Air Force had other priorities competing for budget dollars. The F-15 Eagle program, the B-1 bomber debate, a nuclear deterrence posture that still consumed the bulk of strategic thinking. Precision-guided munitions occupied an awkward institutional position. They had proven themselves spectacularly against a single bridge in a war America was losing politically. The question inside the Pentagon wasn't whether the weapons worked. The question was whether Thanh Hoa represented the future of air power or just a footnote. Weldon Word kept working in Dallas. His team refined the Pavway series through the 70s, improving seeker sensitivity, expanding the guidance kit to fit larger bomb bodies, reducing cost per unit. By 1978, a Pavway kit added roughly $3,000 to the price of a Mark 84 general-purpose bomb. $3,000 to turn a dumb weapon into a smart one. According to an Air Force cost-effectiveness study from that period, a single Pavway achieved the same expected damage output as approximately 100 unguided bombs delivered against a hardened point target, 100 to 1. The economics were so lopsided that the only real argument against full adoption was production capacity. The proof came in 1991. Desert Storm turned the Thanh Hoa data PowerPoint into a doctrine. Coalition aircraft dropped approximately 17,000 precision-guided munitions during the Gulf War, less than 8% of total ordnance expended, but those weapons accounted for roughly 75% of the damage inflicted on strategic targets. Bridges, bunkers, command centers, communications nodes. The Iraqi military had studied Vietnam. They had built hardened shelters and dispersed their forces. None of it mattered against weapons that could fly through a ventilation shaft. The North Vietnamese had been right to celebrate the Dragon's Jaw's survival through the 60s. Their defenses were competent, their repair crews extraordinary, and their anti-aircraft gunners killed brave American pilots flying an impossible mission with inadequate tools. What they couldn't have anticipated was that the bridge's very stubbornness would become the catalyst for a revolution that made every other bridge on Earth vulnerable. The Thanh Hóa Bridge didn't just prove that precision munitions worked. It provided the failure data, years of it, exposed in painful detail across hundreds of after-action reports, that justified the investment. Without those 871 failed sorties, the Paveway program might have remained a curiosity in the Texas Instruments catalog. The bridge's refusal to fall was the best argument Weldon Word ever had. The Thanh Hoa Bridge was rebuilt after the war. The North Vietnamese restored it to full service by 1973, and it carried traffic along Route 1A for another 2 decades before a modern replacement span was constructed nearby. Trucks still cross the Song Ma, at roughly the same point where Reisner's Thunder Chiefs rolled in at 400 knots in April of '65. The river still floods, the valley still narrows. Robbie Reisner survived 7 years as a prisoner of war in Hanoi. Shot down on his second tour in September of 1965, not over the Thanh Hoa Bridge, but over another target en route Package 6, he endured solitary confinement, torture, starvation rations, and conditions that broke men with less stubbornness than a concrete abutment. He came home in 1973, continued his Air Force career, and retired as a brigadier general. He rarely spoke publicly about the Thanh Hoa strikes in specific tactical terms. The bridge was one mission among many, one frustration in a war full of them. But in a 1977 interview with an Air Force historical officer, Reisner was asked whether the early raids against the Dragon's Jaw had been worth the cost. His answer was brief. He talked about the pilots and the planning, about the weapons they'd been given. Then he paused. "We did everything right except bring something that could kill it. You can fly a perfect mission and still not scratch the paint. We scratched a lot of paint."